Radians are not commonly tested on the ACT, however, they do occasionally appear. So in this video, we are going to review radians. Radians are the SI unit of measure of angles that offer a more natural alternative to using degrees. By that I mean that degrees are arbitrarily based on a 360 system, whereas radians are actually based on the circle itself. So a circle has a total of 360 degrees. In radians, that is equivalent to 2 pi radians. In other words, we can very easily convert from radians to degrees or from degrees to radians by setting up a proportion. So if you take the radians over 2 pi and set that equal to the degrees over 360, you can solve for either radians or degrees depending on which value you have. Of course, that proportion can be simplified further by multiplying both sides of the proportion by 2, in which case you get radians over pi is equal to degrees over 180. In the figure on the left, we can actually see a circle with degree measures and radian measures, so we can see what they look like side by side. Now let's talk about why radians are a little bit more natural to use than degrees. It all has to do with measuring arc lengths. So in a circle, the length of an arc intercepted by a central angle is equal to the measure of the angle in radians multiplied by the length of the radius. So if we had a unit circle, meaning we have a circle with radius 1, that means the measure of a central angle in radians is equal to the length of the intercepted arc. So in the circle here, if theta is in radians, r is the radius, and s is the length of the intercepted arc, then s is equal to r times theta. It's that simple. Now that we have a deeper understanding of radians, let's do just a couple of practice problems. Exactly how many degrees is 5 radians? So if we have 5 radians over pi is equal to the number of degrees over 180. Solving for degrees, all we need to do is multiply both sides by 180. And that is going to give us degrees is equal to 900 over pi. And that's going to be the exact number of degrees. Of course, if we wanted to approximate, we would just take 900 and divide it by pi. Exactly how many radians is 48 degrees? So again, we'll take radians over pi is equal to 48 over 180. So that'll give us 48 pi over 180, which we can simplify that by realizing that 48 and 180 are both divisible by 12. So that'll give us 4 pi over 15. So 4 pi over 15 radians is equivalent to 48 degrees. What is the exact length of the arc intercepted by a central angle of a circle with a measure of 4 radians if the circle's radius is 1? Well, this is really simple. The radius is 1, so the length of the intercepted arc is just going to be equal to the number of radians. So the length of that arc is just going to be 4.